Okay, so we have permutation problems here in which we're going to pick up examples of word problems, real life problems when it comes to arrangement of things. So we'll have problems based on numbers, problem based on arrangement of people and various other types. Let's see what we have in this interesting topic. So we have in how many ways 5 persons can stand in a line for a group photograph. So it is an arrangement of group. So there are two ways of doing it. The first, maybe you could pick up the first person. You could pick up the first person in 5 ways. Then the second person in 4 ways. And the third person in 3 different ways. And second one in so many ways. And last one, of course, in 1. So that means you're picking up any 1 out of 5 and put him on the first place. Then second place could be picked out of any 4. So hence it's eventually 5 factorial, which is actually 5p5. If you look at 5p5, it is going to be 5 factorial upon 5 minus 5 factorial, which is 5 factorial upon 0 factorial. And we know the 0 factorial is the same as 1. Hence this is 5 factorial. So in short, 5p5 and 5 factorial are the same, or in other words, npn is the same as n factorial. So eventually, and also remember that whenever n people are selected and the same n are arranged, you can always arrange them in n factorial ways. So here you're picking up 5 people, and in this case you arrange them in 5 factorial ways. So we have the answer as 5 factorial. Let's check all 5 factorial. Let's take the next one. In how many ways letter of the word Sivan can be arranged? Now you're not picking up any 2 or 3, you're picking up all the 5 and you're arranging them 1, 2, 3, 4, 5. 5 of them. So again this is going to be 5 factorial or 5p5. Right? Same as the previous one, and yes, we have it that way. Now, here we have a different situation. We have Mr. X and Y, that is, enter into a railway compartment having 6 vacant seats. The number of ways in which they can occupy the seats is what? So, we have 2 people entering and they have to pick up out of the 6 seats any 2. So that means we have R as 2 and N is 6. And there are so many ways in which they can arrange themselves in the picked up seat. So it's going to be eventually NPR or 6P2, which would be what? 6 factorial upon 6 minus 2 factorial, which is 6 into 5 into 4, and this is going to be 4 factorial. This is also 4 factorial. This gets cancelled, hence we get 30. So there are 30 ways in which they can occupy the seats. The 2 people who can pick up any 2 of the 6 positions. So answer is 30. Yes, and we do have 6p2 or 30. Then in a group of boys, the number of arrangements of 4 boys is 12 times the number of arrangements of 2 boys. The number of boys in the group, that means here n is not known. In other words, when you're picking up 4 out of these n, which is np4, then it is 12 times 2 boys picked up out of this, that is np2. So np4 is 12 np2, which is the same as n factorial upon n minus 4 factorial is equal to 12 into n factorial upon n minus 2 factorial. So this gets cancelled. So this goes over here. So you get n minus 2 factorial as we did earlier as n minus 2 into n minus 3 into n minus 4 factorial upon n minus 4 factorial, which is 12. So this gets cancelled, and hence we need to pick up out of these. So out of these we can solve the equation, or let's pick this up and see 10 minus 2, n minus 8 into 10 minus 3, 8 into 7 is 56, not 12, so this is out of question. 8 minus 2 is 6, 8 minus 3 is 5. 6 into 5 is not 30. So is not 12. Hence we have. What about 6? 6 minus 2 is 4. 6 minus 3 is 3. 4 into 3 is 12. So n has to be 6. So this is how we can solve it, or open the bracket and solve it. It will be wiser to substitute because we got a simpler form of an equation. So the total number of boys from whom you're selecting 2 or 4 boys is going to be 6. And we do have it that way. Okay. Now, 12 school teams are participating in a quiz contest. Then the number of ways of first, second and third positions may be 1 as what? So there are various ways of doing it. So any one of the positions of, say, the first position can be picked up by 12 schools in 12 different ways. So now remaining are only 11. Now the second position can be picked up by any 11 of these. So and it is a case of and. So it's going to be into. So for the second position there are 11 contestants, one who has got away, assuming that one person is obviously not going to get first and second. So remaining the number of schools left will be 10. So the third position can be picked up in 10 different ways, which is going to be 1320. So it's 1320. Another way of doing it is you have 12p3. 12p3, that is, you're picking up 3 positions out of 12 and arranging in so many ways, which is the same as 12 factorial upon 12 minus 3 factorial, which is 12 into 11 into 10 into 9 factorial upon 12 minus 3 factorial, that is 9 factorial, which again turns out to be 1320. So this is how we get 1320, and yes, we do have that. So what do we have here? The next one is, if the letters of the word, we take it as of the word, daughter, are to be arranged so that vowels occupy the odd places, then number of different words are what? So now we have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 words, 8 letters, 1, 2, 3, 4, 5, 6, 7 and 8. Now, and there are 1, 2, A, U and D as the vowels, which are going to occupy this space, this space, this space or this space. So the vowels, 3 vowels have 4 places that they can occupy. So the 3 vowels can occupy 4 places in 4p3 ways, and the remaining that is letters, which are going to be D, G, H, T, R. So once these vowels occupy 3 places, out of the 8 places there are 5 more places left. So it's going to be 5p5. So the 5 out of the 8 letters, once 3 of occupied. Now all 4 are not going to be occupied simultaneously by the vowels because there are only 3 vowels. So out of the 4, any 3 is going to be occupied, and the remaining 1 extra will be occupied by a consonant. So it's going to be 4p3 into 5p5. So this is for the vowels and this is for the consonants. So this is going to be turning out to be 4 factorial upon 4 minus 3 factorial, which is 1 factorial, into 5p5, that is 5 factorial. 4 factorial is going to be 4 into 3 into 2, and 5 factorial is 5 into 4 into 3 into 2. So it's going to be 24 into 120, which will turn out to be 2880. So it's going to be 2880. So among these, this is how is the answer. So there are 2880 words that could be formed. Of course, it goes without saying that all these words need not seriously make sense. There may be some formation of these letters, and hence our option here is 2880, and yes, we do have it right. Then what do we have next? Okay, now we have a situation. The number of ways in which the letters of the word mobile can be arranged so that consonants always occupy the odd places. So consonants are occupying. So how many consonants we have is M, B and L are the consonants, and O, I, E are the vowels. So there are 6 places. So the consonants are going to occupy the odd places. So obviously, they're going to occupy the odd places. So obviously, the vowels will occupy the even places, that is 2, 4 and 6. So there are 3, so it's going to be 1, 2, 3, 4, 5, 6. So the consonants are going to occupy this, this and this. This is going to be for consonants and these are for vowels. So the consonants can occupy these 3 places, 1, 3 and 5 in 3 consonants and 3 places. So it's going to be 3 factorial. Coming back to the vowels, there are 3 vowels occupying 3 places. So they will also occupy 3 factorial ways they could arrange themselves. So there are 3 consonants arrange themselves in 3 factorial ways and 3 vowels occupy themselves in 3 factorial ways. Now 3 factorial is 3 into 2 into 3 into 2, which will turn out to be 6 into 6, 36. So we have 36 as the answer here. And yes, we do have 36. Okay, the next one coming our way is, yes, 5 letters are written and there are 5 letter boxes. The number of ways the letters can be dropped into the boxes. So there are 5 letters and which have to be dropped in 5 boxes. So there are 5 spaces and 5 to be accommodated. So it's going to be 5p5, which is 5 factorial ways in which they can be dropped into the various boxes. So it's going to be 5 into 4 into 3 into 2, which is turning out to be 120. And among these, this is the answer, and we do have it that way. Right. Next we have here is this way. A code word is to consist of 2 English letters from the alphabet followed by 2 distinct numbers between 1 and 9. Now it goes without saying that including 1 and 9. Okay, so how do we do this? We have to pick up 2 letters from the English alphabet. So it's going to be 26p2 and followed by 2 distinct numbers between 1 and 9. So between 1 and 9 and 2 is 1, 2, 3, 4, 5, 6, 7, 8 and 9. So you're picking up 2 numbers out of 9. So it is going to be 9p2. So it's going to be 26p2, which is 26 factorial by 26 minus 2, 24 factorial. And remember, it's an AND. So both these have to occur simultaneously, and this is going to be 9 factorial by 9 minus 2, 7 factorial. So it's going to be 26 into 25 into 24 factorial upon 24 factorial into 9 into 8 into 7 factorial upon 7 factorial. This gets cancelled. So ultimately it's 26 into 25. Let's see what we get there. So it's 26 into 25 into 9 into 8, which turns out to be 46,800. So it's 46800. So understand, this is a simple case. So again, remember it's and this occur simultaneously. So our correct answer is 46,800. And we do have it that way. Next comes, how many 6-digit telephone numbers can be formed using 10 distinct digits? You have to pick up 6 out of 10 and arrange. So it's going to be 10p6. As we understood this, it's going to be 10p6. Nothing much to think about. It's going to be 10p6 because you have 6 digits you have to pick up out of 10. So it's 10p6. Furthermore, we have this case wherein we have 7 books have to be arranged in such a way so that 2 particular books are always at first and last place. So the 2 books, so they could be A and B. They are in the first place and last place. And the remaining 5 are arranged in 5 factorial ways. But there could also be B and A. There are 2 cases. So it's going to be either A is in the first place and B is in the last place, or B is in the first place and A is in the last place, and the remaining books, that is 5 of them, are arranged in 5 slots within themselves. So it's eventually 2 times 5p5, which is going to be 2 into 5 factorial. 5 factorial we have done earlier is 120. By the time you start doing this exercise, you'll remember the factorial values are simple ones, like 3 factorial is going to be 6, 4 factorial is 25, 5 factorial is 120, 6 factorial is 720, and so on and so forth. So this becomes 240. So understand this. Candidates have a tendency to skip this part. It's a permutation. So they may often tend to take just 5 factorial because these ones are fixed places, but do not dispense off with the possibility that they could rearrange themselves. If the question was told one particular book was in the first place and the other one in the last place, then there is only one possibility. Here they have picked up 2 books which could occupy the first and last place, which could mean either of them could occupy either of the places. So hence it's 2 into 120, that is 240. So the correct option is 240. And yes, we do have it that way. Then we have this. A garden having 6 tall trees in a row. So let's draw those 6 trees. 2, 3, 4, 5, 6. In how many ways 5 children stand, one in a gap between the trees? So we have this place, this place, this place, this place, and this place. So between the trees, there are only 5 gaps, and these 5 gaps have to be occupied by 5 children. So if it was told 3 children, it's going to be 5p3. But here it's told there are 5 children who have to occupy 5 gaps. So what are the ways in which they could arrange themselves? It's going to be all the 5 are going to be exhausted by all the 5. So it's going to be 5p5, which is 5 factorial. And as we said, 5 factorial is nothing but 120. So do we have that option here? Yes, we do have 120. So it's going to be 120. And yes, we do have it right there. Moving on from here, we have the next interesting case. We have, in how many ways 3 prizes out of 5 can be distributed among 3 brothers equally? So there are 3 prizes out of 5 which have to be distributed among 3 brothers equally. So we need to pick up 3 out of 5. So it's going to be 5p3, which is going to be 5 into 4 into 3 factorial upon, into 2 factorial upon 5 minus 3 factorial. It's going to be 60 into 2 factorial upon 2 factorial. So it's going to be 60 ways in which the 3 prizes could be distributed among the 3 brothers. So among these, this is the right option. And we do have it like that. Okay, then, so now the next one has it this way. A man has 3 sons and 6 schools within his reach. In how many ways can he send them to school if no 2 of his sons are to read in the same school? Which means that each of them goes to a different school. So there are 6 school 1. So 1, 2, 3, 4, 5, 6. And he has got son 1, son 2, son 3. So each one goes to a different school. So that means you have to select 3 schools out of 6. So that each son goes to it. So it's going to be 6p3, which is going to be 6 into 5 into 4 into 3 factorial upon 6 minus 3 factorial, which is 3 factorial. This gets cancelled. So it's going to be 120. That is, among these, the answer is going to be 6p3. 3. So he is selecting 3 schools ultimately out of 6. So the question looks a little deceptive because there is one more additional number 3 out of 3. So you should understand, which eventually means, translated means, you have to select 3 schools out of 6. That's what it means. And we do have it as 6P3. Okay. Now we have another case. There are 10 trains plying between Calcutta and Delhi. The number of ways in which a person can go from Calcutta to Delhi and return by a different train is what? This is an easier method of doing it. So suppose he goes to Calcutta and there are 10 trains available. So he may pick up for the journey to Calcutta a train out of 10 in 10 different ways. Understood? Why? Coming back, he doesn't pick up the train in which he has gone to Calcutta. So one train less is available. So he has to choose out of the remaining 9. So that means there are 90 ways in which a person can go to Calcutta and back, from Delhi to Calcutta and back. There are 90 ways as per this condition. So among these, the answer is 90. If you look at it, the same thing can also be done this way, that we can do it by the process of selecting 2 out of 10 without repeating, which is, if you remember, 10 into 9 is actually 10 factorial by 10 minus r factorial, that is 10 minus 2 factorial, that is 8 factorial, which is the same as 10p2. That means now logically you're picking up 2 out of 10 without repeating any one of them. So the first one that you picked up is not being repeated. So it is 10p2, which can also be done. Hence you can do it by 10p2 or using basic logic as 10 into 9. Okay. How many words can be formed with the letter of the words Oriental so that A and E always occupy odd places? So we have 1, 2, 3, 4. So we have 1, 2, 3, 4, 5, 6, 7, 8. And we have A and E always occupy odd places. So it's going to be A and E. So the odd places are 1, 2, 3, 4. So A and E, there are 2 A and E which are going to occupy 4 places, hence in 4p2 ways, and 2 of them have gone. The remaining 6 will be occupying in 6p6 ways or 6 factorial ways. So which is the same as 4 factorial upon 4 minus 2 factorial into 6 factorial. 6 factorial, if you remember, is going to be 720. This is going to be 4 into 3 into 2 factorial upon 2 factorial. So it's eventually going to be 720 into 12, which is going to be 8640. So you understand the logic? If we understand the logic, it's going to be, suppose these are the letters. Now what they are, we are not very, there are so many possibilities. But it is clear that A and E out of these, that is, will occupy. There are chances of it occupying any 2 out of 4 odd places. So it's going to be 4p2. This is for the vowels A and E. And the remaining letters, that is O, R, I, N, T, L, they will occupy the remaining 6 places in 6 factorial ways. So it's going to be 8640 ways in which you can organize it. So our correct answer is going to be 8640. And yes, we do have it that way. Okay. Now here we have a situation wherein you have the number of arrangements in which the letters of the word Monday can be arranged so that the words thus formed begin with M and do not end with N. In other words, the word always has M in the beginning and the last one is not N. That means it could be O, it could be D, A or Y. So that means this place can be occupied in 4 ways. this last position can be occupied by O, D, A or way. So there are 4 ways in which it is occupied, and this is occupied only in one way. And if one of them goes over here, that is N, the remaining, how many words do we have, letters do we have? 1, 2, 3, 4, 5, 6. Out of that, 2 of them have gone here. So the remaining 4 places are occupied by the remaining 4 words in 4 factorial ways. So it's going to be 4 factorial. That is, the first position is occupied by M, which is only in one way. The letters in between can be occupied by the letters including N in 4 factorial ways. And the last position is occupied by all the letters excluding M and N, that is O, D, A and Y in 4 ways. So it's going to be 4 factorial into 4, which is going to be 24 into 4, that is 96. So there are 96 ways such arrangements are possible. So we have 96 as the answer for this. Remember one thing here, it is not going to be 4 factorial, because in fact it is going to be 4. You can even write it as 4 or you can write it as 4p1, because you are selecting 1 out of 4. We can even be writing it as 4p1, which is the same as 4 factorial upon 4 minus 1 3 factorial, which is 4. So we can write 1 position selected out of 4, the remaining 4 positions selected by 4. So it's 4 factorial. So it's 24 into 4, 96. And yes, we do have it that way.